Okay, if you're interested in any of our previous lessons, they are all on our website. Under the one we just finished last week is trigonometry. We basically went through all the foundational ideas in trigonometry. So all those recordings and the quizzes are available. You can still do those quizzes and you can get your answers straight away. So for those of you who have done the quizzes, you'll know you get your answers straight away and you get your scores straight away. And you can do them as many times as you want. I think the last time we counted 17 was the highest number of attempts. Maybe you don't want to try it 17 times, but you can try it as many times as you want. Okay, so after we are done here with analytical geometry, we will tackle functions. That's a big topic in paper 1. And then we are probably going to start looking at calculus towards the end of the term. Another announcement in terms of our housekeeping this evening is that the exam prep classes were announced last week, and they will be on the 14th and 21st of May at 3 till 4:30. Here's a list of names of those people who have signed up. So check that your name is there. I see some of our participants, some of our learners are here. If you still would like to sign up and your name is not on the list, ask your parents to register tonight, please. The link was sent to you last week. I think it is at an additional charge of 200 Rand for both of these. So for paper 1 and for paper 2 together is 200 Rand. And that will hopefully help you get ready for your June exam. Okay, I think that's everything, Ms. Coco. Oh no, wait, I've got one more thing that we do on a Tuesday, which is shout outs. Speaking of quizzes, these 3 people got top 3 scores in the quizzes. Some of them are here for a second and a third time. So well done to these guys. You've done very well. And who knows, maybe next week we'll see some new names on the board. But well done to Oratile, Masindelo, and Cassandra for acing your quizzes last week. But remember, like I said, it's a no stress quiz. Kayla, will it be a full paper? Yes, I think Ms. Lee, who teaches grade 12 as well here at Watobe, she's going to be taking you for that exam prep, and I'm sure she will make sure that you get through a full paper for paper 1 and paper 2. Right. Okay, I think we are now ready to start our lesson for this evening, and we're going to ease into it by just re-looking some of the ideas around analytical geometry. So analytical geometry is basically geometry that we do on the Cartesian plane. So you're welcome to take notes and to write down as we go. In fact, I encourage that you do, just like you would in a normal lesson. And you can write down the summary of the different formulae that we need in analytical geometry. Starting with the distance formula. So if I have 2 points and two coordinate points, x1 and y1, and x2 and y2, I can calculate the distance between those 2 points using this formula. Now, remember, you do not need to memorize these. These will be on your formula sheet at the end of the year. But it is always nice to have them handy so that you don't have to search through a textbook to find them while you are doing your work. So I would recommend that on a piece of paper you write these down and keep it with you throughout the course of our lessons so that they're easily accessible and you can find them quickly without having to scratch too much. Okay, so gradient is something that we have learned since grade 9. Gradient, same. If we've got the 2 points, we subtract the y's and we divide it by subtracting the x's, and that will give us the gradient. Also sometimes referred to as the change in y over change in x. If our gradient is positive, then it will slope in the positive direction. And if our gradient is negative, the line will slope the other way. Slope, gradient, all of that all means the same. So if we have a line that goes in that direction, then it is sloping negatively. Okay, so positive gradient, negative gradient. We're going to talk a bit more about gradient just now, after we have a look at the midpoint. So the midpoint, again, if you have two coordinate points, x1, y1, x2, y2, then the midpoint is the average of the x's and the average of the y's. That's just because it's the midpoint. So we can take the two values divided by 2, and we can get the x coordinate and the y coordinate of the midpoint that way. Okay. The equation of a line y equals mx plus c, where m is the gradient. So a lot of this you also learned in functions, so there is a bit of overlap with functions, and c is the y-intercept. Okay, so those values have special meaning. They give you the gradient and the y-intercept. Now, parallel lines, back to some facts about the gradient. It's actually quite a significant number, or something that we can interpret in many different ways and tell us a lot of information. So parallel lines, if lines are parallel, the gradient of the two lines are equal. And if they are perpendicular, then if you multiply the two gradients together, you must get -1. Alternatively, we can think of it as tip and change the gradient. So for instance, if my first gradient of my one line is 3 over 2, and the two lines that I'm working with are perpendicular, then I can tip the gradient and make it 2 over 3 and change the sign. So 3 over 2, the gradient of the other line will be -2 over 3 because the lines are perpendicular. Okay, so those are the things we're kind of going to need this evening. And just in terms of an overview for the course, if you did watch the introductory video, we are going to go through these basic ideas this evening. But by lesson 3, 4, 5, we are going to start looking at circles and finding the equation of the tangent to the circle, which is more your grade 12 stuff. Okay, so we are building up most certainly to get to your grade 12 content. But first, let's get a handle on this stuff, because all of this is still in your grade 12 exam as well. Everything that we are going through will be examined in grade 12 as well. Okay, so I'm going to give you a moment. Circles, dun dun dun. My name is Coco. Do you have a particular feeling about circles?
I have a toxic relationship with circles, man. You know.
There must be a phobia for circles. We must look it up. So Ms. Coco and I chatted the other day about fear of large objects, and that was called megalophobia. So maybe, Ms. Coco, there's a fear of circles as well, which is what you've got.
Yeah, I have that.
Circular shapes. Okay, so in the diagram below, we've got A is 2 and 3, B is -1 and -1, C is K and -4, and there are 3 points on the Cartesian plane. Okay, and we're going to start off with question 1. Calculate the length of AB. Right, so if we are calculating distance, this is where you need your formulas handy so that you don't waste time looking for them. So I hope you made a quick summary of those formulas. And we're going to start let's write in green. Yes, let's do green. Red is it's quite loud. Let's go for a calmer green color. Okay. Let's keep the zen going. Okay, so in green, the length of AB, and you can start off by writing your formula, but you don't have to, okay, as long as you substitute correctly. But if you don't know your formula that well, and you're just kind of getting used to this, you can write down x2 minus x1 plus y2, squared, plus y2 minus y1 squared. Okay, and if you also, let's just check, yep, that one's right. And make sure that when you do write it down from your formula sheet, that you write it down correctly. Okay, so there's a lot of little checks that you can do to make sure you get all of your marks. So we can now I'm going to label this x1 and y1 and x2 and y2. And if you do that, then you can also make sure you get your right coordinate points. So x2 is minus 1 minus 2. And I'm going to square it. And like I say again, make sure that you've got your calculator and your pen and your pencil right there with you. Everything you need to work out as we go. Okay. So I'm going to give you a moment to work that out, and then please pop your answer in the chat so that we can see what you're getting up to there at home while we are here. Oh, Liam was quick. Ashanti, I think you just need to check that. Make sure that it is correct. Okay, make sure you know how to use your calculator for this stuff. Okay, many of you are getting 5. Solomon's saying 5. Michelle's saying 5. Ashanti, were you just... Glad you corrected that one. Well done. Okay, everyone, I can see you know this is 5. Good stuff. Excellent. Okay, let's carry on to the gradient of AB. Let's do that one as well, and then pop it in the chat as soon as you're ready. Don't just use your calculator. I want you to write down as well so that you can practice for those exams, because answer only does not get you full marks, okay? Answer only does not bring home the bacon. You got to show all your working. Some of you are way too quick to have written it all down. Okay, so minus 1, minus 3, y2 minus y1 over x2 minus 2. Wonderful. It looks like our matrix know how to calculate gradients, which is good stuff. 4 over 3. And remember, the calculator is your friend, so always check if you are worried that you might make a little mistake or something. Right, so write down the gradient of BC if AB is perpendicular to BC. Okay, so the gradient of AB we've just said, and also write down as you go the things that you find. So because these questions always lead on to each other and you don't want to have to search through your work. Okay, no one's given the right answer yet for the gradient of BC. Careful. Ah, there we go. There we go. There's the right answer coming in now. So just again to repeat, remember if we have perpendicular gradients, we can tip and change the gradient. And that is going to, so we tip 3/4 and change the sign. -3/4 because they are perpendicular. And multiplied together, those two values must give you -1. Okay, yes, there's the minus. Don't forget the minus. Okay, so determine the value of k. Let's see. So the value of k. Now, let's just see, no other information is given. So any ideas how we can determine the value of k? Pop it in the chat if you think you know. I'm going to take a few suggestions and then we can maybe see what we can do. Any ideas how we're going to find k? Let me just put that back up. Use the midpoint. Let's just be careful because it's k is not the midpoint. Kayla's saying find the equation of a line, equate the two gradients, then cross multiply. Okay, some ideas are coming in. Okay, those of you who are saying midpoint, just be careful. C is not the midpoint of anything, okay? So C is just a point. So we can't use the midpoint. There's two things we can do so far that I like is the equation of a line. I think that's a good one because we've done all the work with the gradient. We just need to find the y-intercept. The other thing we can also do is work with the gradient. I think let's practice finding the equation of a line. Just to explain the logic behind finding the equation of a line, if we find the equation of BC, then we can find the coordinates of any point on that line. So far we have a y coordinate and k is actually an x coordinate. So if we find the equation of BC, we can find the corresponding x coordinate for point C. Okay, so let's do that. What are we looking for? We're looking for y equals mx plus c. And the gradient of BC, of line BC, is -3/4x plus c. To find what c is, we sub in a point. The point that we have with a y coordinate and an x coordinate is -1 and -1. So we're going to sub that back in. So y is -1, -3/4 times -1 plus c. I'm going to multiply that out. That's going to give me 3/4 plus c. Subtract the 3/4 on both sides. So -1 minus 3/4 gets me -7/4. So the equation of that line is y equal to -3/4x minus 7/4. Great. Just replace Tato, just replace your m with an x. And if you write plus minus like that, you need to make up your mind. Is it a plus or is it a minus? Okay, so it's definitely a minus. Where did we get -1? -1, point B. Point B is -1, -1. No worries, no worries. We love questions. We love answering questions, especially if they're hard. Makes us think. Okay, so that's still just half the work done. I just want to see, can we get a thumbs up in the chat if you're happy with how we found the equation of this line? or a thumbs down if you're not happy. Just indicate in the chat how you're feeling about finding the equation of the line. Got some thumbs up. Wonderful. Good stuff. Good stuff. Okay, so this is just half the work done. We still now have to go ahead and find the actual coordinates for K. So if you check, we have the Y coordinate at C. So if we sub that into our equation of a straight line, we can find that X coordinate that they've called K over here. So I'm just going to go right ahead and make that xk, because that's what we are actually solving for. We used -1 and -1 just to answer your question, Lati, because that point is on the line BC. We can't use this point because we can't use point C because we are solving for K. So we use what is known. Remember, always use what is known to find what is not known. And that normally involves making an equation. Okay, I want to get rid of all these fractions to now solve for K. So I'm going to multiply right through with a 4. This is going to give me -16 minus 3K minus 7. And I'm going to add 7 on both sides to get to get rid of the -7. We add 7 on both sides. We're just solving the equation. And if -3K is -9, I can divide by -3 on both sides to get K is equal to 3. Right. Lots of work. That would probably be a 5-mark question. Okay, can I just get another round of check-ins? How are we doing with K? Everyone happy with how we found K? Just put a thumbs up in the chat or a thumbs down if I need to explain again. Okay, can we not divide by -1? Yes, that's what we did. Well, I divided by -3 at the very end. If you want to do that at the start, that's fine too. Okay, lots of thumbs up. Now we are going to, let's go on. I think we can proceed to the next question. Determine the midpoint of AC. And I'm just going to put the question back up here so that you can all see where AC actually is. Now, I'm actually going to scroll to the side here to make some space. Okay. The midpoint of AC. Now, remember, we just found the coordinate K. We found it here. So this coordinate is 3. So to find the midpoint, we have to use the coordinates of A and C to find the midpoints. Okay, pop your answer in the chat when you've done it. Midpoint. Midpoint, remember, we just take the average of the two coordinate points. Just to be clear, we are doing question 5. We are finding the midpoint of AC. We just found the value of K, so that's 3. So you have both coordinate points now, and you're able to find the midpoint. Yes, that's looking good. Taniko and Tubile, well done. That looks good to me. Pop your answer in the chat. Good stuff, Kayla, Michelle. Okay. Okay, this one. Okay, I'm going to do the midpoint here. Question 5. So we literally just go 2 plus 3 divided by 2, because those are the x coordinates at A and C, and 3 minus 4 divided by 2. And that will simplify to 5 over 2 and minus a half. Well done, everyone. It looks like many of you got that one right. Excellent. Okay. Last question for this one. And this is something that requires a little bit of additional thinking. So I'm just gonna rub this out so that we can see. Okay, so determine the coordinates of a point D such that the quadrilateral ABCD is a rectangle. Okay. Any ideas how we're going to do that? Pop them in the chat and then we can see what we come up with. Any ideas, suggestions? How will we find this coordinate D? But that coordinate D must be placed in such a way that ABCD is a quadrilateral, is a rectangle. So we already know from previous calculations that these two lines are perpendicular. Can we reflect a point? Okay. Midpoint of AC. Okay. Any other ideas? Everyone is stumped. Translation. Okay. Okay, I'm going to show you the way that I think is a good way to do it. I think this might be a good idea. Look for the equation of the parallel line to it. The midpoint of BC should be the same as AD. BC the same as AD. Okay, but we are actually going to work with the gradients, because remember with a rectangle, the gradients of the opposite sides are the same. So we have the gradient of AB. So the gradient of AB we calculated. It was over here. That was 4 over 3. And the gradient of BC we then said was negative 3 over 4. Okay, so this point D, we can all probably agree that it will be somewhere here, because that will make it a rectangle if we place it somewhere here. So whatever this distance is here must be, or whatever that gradient is, it must be the same as the gradient of AB, because those lines are parallel if it's a rectangle. And so I'm just going to make a ghost D over here, because we know that it's going to be here, but we don't exactly know where it's going to be. And then the gradient of AD also needs to be the same as the gradient of BC. Okay, so we call this finding a point by inspection. Okay, so the next thing we can do is to make a little triangle like this, because we know with the gradient that the change in y and the change in y over the change in x is 4 over 3. So this distance must be 3. That's the change in x. 4 over 3. Then it must be the same over here, because these lines must be parallel. So this gradient is also 4 over 3. So this distance must also be 3, and this must be 4. And we found this was 3. Okay, so if I move 3 units on the x that way, I'll get to all the questions in the chat just now. If I move 3 units that way from 3, where will I be? And if I move 4 units from here, where will I be? Okay, so if I move 3 units on the x in that direction, that will actually give me, what is 3 plus 3? That will be 6. And 4 units upwards from -4 will give me 0. So that point is actually going to be at 6 and 0. Okay, I'm drawing lots of stuff because I'm explaining, but you don't have to draw all of this in. Okay, believe it or not, this is actually only a 2-mark question because you're just working with the gradients. All right. Okay, I'll do it one more time. So the gradient, we're gonna, because this is wherever we place point D, we have to create a rectangle. So for the rectangle, the opposite sides are parallel. So if we look at the gradient of AB, the gradient of AB is 4 over 3. So wherever I place this point D, the line that it makes, this line CD. Okay, so I'm just going to make it here. I don't know what the coordinates are going to be, but I can imagine to create a rectangle, D must be over here. So the gradient of CD must also be 4 over 3 because the lines are parallel for it to be a rectangle. So the change in y over the change in x gives me the gradient. So the change in y is 4. So I look at this coordinate point, -4, and I would go up by 4 because that is the change in y for the gradient. So -4 upwards to 4 will give me 0. -4 plus 4 gives me 0. And then this k, we calculated it in a previous question. In question 4, that was 3. So if I move on the x-axis 3 units to the right, then 3 plus 3 gives me 6. And those will be the coordinates of D. Yes, it will always work. Always works. Okay. Right. I've got a question up here. We are almost out of time, but I think we must work for the next few minutes and just see how far we get before we have to start our quiz. So I'm going to leave you for about 3 minutes or so, and I want you to just do question 1. Let's see what we're going to have time for. Question 1, question 2, question 3. Yeah, let's do 1, 2, 3, and we'll check back in about 3 minutes to compare our answers. So don't put answers in the chat until I ask. Just wait a little bit to give everyone a chance to do them. Okay, 3 minutes are up, so you're welcome to put your answers in the chat. If you've got some already, let's see how you're doing. Okay, so we got the gradient. Remember, you have to simplify your gradient. So whatever, if you get 4 over -12, then you need to simplify it to -1/3. Equation of a line is 14 over 3. Well done. And D is 4. Okay, excellent. I agree with all of your answers. Wonderful. Okay, so let's see how we got there. Okay, so for question 1, the gradient, you could have done it either way around. I went 6 minus 2 over -4 minus 8. And that is 4 over -12, which you have to simplify to -1/3. Then to find the equation of the line, now we have the gradient, so we can pop that into our equation of a straight line. And then we sub in a point. I subbed in 8 and 2. You could have subbed in -4 and 6 as well. Either one will do. So I did 8 and 2. And I got 2 is -1/3. So 8 plus C. And then we just have to get C by itself. We multiply the -1/3 with 8 and we add it to the 2 on the other side. And then C is 14 over 3. And then lastly, for question 3, D lies on the line QR. We just found that equation. We just found it. It's -1 over 3 x plus 14 over 3. So we just found that equation. If we have an x coordinate, we can find a y coordinate. So if I'm looking for a y coordinate, I can just substitute my x coordinate into the equation of a line, of that line. The x coordinate is 2, so that's what we sub in. And you can pop that into your calculator and you'll get y is equal to 4. Okay, great stuff. I think that is all we have time for this evening. We still have to do our quiz. And Ms. Coco, do we have a poll this evening?
I believe we do. I can do it really quickly right before I put the link to the quiz in the chat.
Okay, let's do our poll.
Somebody's asking, is it not -14 over 3? Kayla's asking.
Okay, we're going to multiply the -1/3 with 8. So -1 over 3, let's check again, times by 8 is -8 over 3. And then we add it to the 2 on the other side. So 2 plus 8 over 3 gives me 14 over 3. I'm quite sure it's positive. Just make sure you add it to the 2, okay? You don't subtract it, you add it.